Yeah, so co-founder at Dilipso, these are some of our products. It's been a very hectic year of starting this company. Previously, I've worked at Datadog and Recurly, and of course, I live here. Let's just jump right into it. So I generally like to start off these things with definitions. So you might be thinking like, what is a plugin system? Well, Wikipedia doesn't have a definition for a plugin system. It does say what a plugin is, and what it says is, in computing, a plugin is a software component that adds a specific feature to an existing computer program. When a program supports plugins, it enables customization. Okay, that means like nothing, right? It's like, it turns out it's kind of one of those abstract concepts where the more accurately you define it, the more fuzzy it becomes. And probably that's a reason why when you hear people say plugins, it's like, what are you talking about? And everyone feels like they're talking about different things. So let's just get some more clarity. Let's look at their use cases, right? These are equally confusing because none of these really seem super relevant in 2023, except for the last one. And I want to kind of spend some time talking about that. So to me, like one of the key parts of a plugin system is enabling third-party developers to extend your application. So let's look at like some real examples. So something that you probably use every day, a browser, which has extensions, right? And you know, the way these work is Firefox like exposes some APIs, and third-party developers who don't work for Firefox can come and build their own software on top of Firefox that creates new functionality for Firefox. And this is great because it's like, you know, Raymond kind of can build and deploy the software at will. He could maybe even get paid for it. And this is the kind of stuff that like the browsers, like you could never, like Google could never build an ad blocker, right, into Chrome. Even Firefox, they get like 500 million a year from Google. They're not going to build that either. So it's like, it gives the community a chance to like build and extend applications in a way that they, you know, see fit. But that's like desktop applications, right? Like Firefox is like a pretty serious application. What about web applications? This is actually very rare, and I'm going to talk about why in a little bit. It's very common in desktop applications, very rare in web applications. But Figma is a good use case that I think probably a lot of you are familiar with Figma. It's like a pretty heavily used in the UI UX world. But Figma is really cool because they even have like a whole marketplace, right? Like you can be a Figma plugin developer. You can get paid through it. Like there's like thousands of plugins. So this is super powerful because the thing I want you to take away is that like it allows you to think of your application more like a platform, right? And not just like this static application where you develop all the features, but a platform on which like other people can build businesses and whole applications. So it's more like thinking about yourself less like, you know, like a Facebook and more like an iOS. Like you're like an operating system, you're building a marketplace and you're building this extendable thing for other developers to build on top of. Does that make sense so far? Yeah. Okay, great.
Oh, I think he has a question. No, I was...
okay, good. Thanks. Yeah, so in order to get a better idea of how this stuff works, we're going to build, we're going to design and then build like a little application that's extendable called Photoshop. And this is like a photo editor. So let's like wireframe this out. It's just going to be a simple 2-panel application where on the right we have a photo that someone loads, and on the left we have a series of filters. And when you add a filter, depending on what filter you add, it like processes the image in some way. So here we're like adding this invert filter that inverts the image. Some of these filters, you know, you might want to give the user the ability to kind of tweak them, change sort of parameters of the filter. But this is the basic idea, right? And you know, we're going to build a proof of concept with like some of these filters, but ultimately, like we want this to be extendable by our users. So we want users to be able to come in, build their own plugins, maybe even sell plugins, like completely, you know, separate from what we're doing as an application, as a business. Yeah, so if you were to build this, starting out, you know, you might have like a folder with your filters in it, and each filter that you add, like to do it in like a pretty clean way, maybe each filter will just be like a JavaScript module, right? And just adding a JavaScript module like adds a filter, right? There's no coupling between your application and your filter code. Like, so anytime I just go paste in a new filter, it should just show up and work. You know, that's just general like separation of concerns. Does that kind of make sense? Like how you might build all the features for this in like a module. So that kind of gets me to my first like sort of philosophical idea here, which is that plugin systems are interfaces. So what a plugin system really is it's like an interface in your application where you've separated things, you've decoupled from it, and right now you're running your code, but in theory you could just run anyone's code as long as it satisfies that interface. So let's design this interface, and we're going to use TypeScript to describe it, but we're writing this in JavaScript, which you'll see later. So the first thing we want in our interface is the ability to like process these images. So this is like not the most efficient way to do it, but it's the simplest way to do it, where we're just going to have our plugin module export a process function that just takes, you know, a byte array for the image data, and this returns a byte array for the new image data. So we just let that plugin decide what to do with that. But remember, we also have like an interface for this thing, right? It's like there could be different parameters that we want to give the user the option to do. So what we'll do is we'll just define this like variable object that just kind of maps to an input, an HTML input. And we're just going to ask the plugin, like, what are your variables? What variables can I change for you? And then we'll just go ahead and render this in React based on those variables. Does that make sense? So the plugin just says, these are the variables and the names of things that you can change and what the types are. And we're gonna build that form. So we're just going to call that getConfig. So we're going to export another function. And when we load this plugin, we're going to get its config and then render that view. Finally, we need a way to like update the plugin. So we're going to go into our input on change and just add a little trigger there and just send the name and the value to the plugin when someone changes it. So if someone's changing a slider or, you know, a number or whatever, it'll send it down to the plugin. And we're just going to call that set variable. So these three functions make up the interface of the plugin. Everyone making kind of sense right now? So let's talk about the implementation. What would it look like to write one of these plugins? Well, it's just a simple JavaScript module. You go in and you just write these three functions, you implement them, and you export them to something above, and it just consumes them and uses them, right? But how does like the user actually get the code in there? Like it's not like they can just send a pull request to your application. Like maybe they could, but you want it to be this kind of separate thing. So you know their JavaScript program is just going to be like in text at some point, right? And they're like uploading it to, let's say, S3, and you're loading it off S3. So it's in like string form, right? Like, and forget about ignore the fact that this changed to CGS format. But it's the same thing. It just exports the three functions. But your code is now like in this string form. And how do we actually like run this? Well, you know, you just evaluate it, right? You evaluate it, and then now you can get access to those functions. And yeah, that's it. That's all you really need to do for a plugin system. But this is not really a good idea. Does anyone know why? Okay, so eval is like really cool. I mean, it's kind of, you know, really powerful concept. So what is it doing exactly? Let's go see. Oh, snap. Okay. Yeah, this says, so MDN like rarely uses such explicit language to say enormous security risk and to never use eval. So it's like, what is going on here? Let's click that. Okay, yeah, there's a lot of bad stuff going on. So don't use eval. If you're not really understanding why, I mean, it's kind of just like opening up a shell into your application for anyone just to go and just run any code they want. So it's dangerous, right? It's like we can't just let people just run arbitrary code in our application. Does that make sense to people? Like, it would be like if someone hacked you and they did a remote code exploit. Like, it's the same thing, but now that's a feature in your application. So someone in your companies would be like, whoa, this is not, we can't do this. Okay, but wait a minute. So like we're web developers, right? Like we take untrusted input all the time. Like, people put all sorts of stuff in forms and we just render it and we're fine, right? Like, React takes care of it, or Rails or whatever framework we're using. Why can't we just do the same thing with JavaScript? All we need to do is just sanitize the JavaScript, right? It's like, this is a great idea. Everyone's doing it. Cool, let's go. Let's ship it. Okay, what's going on here? So all of these projects died about 5 years ago with a barrage of CVEs, right? It's like, this was not a good idea. I'm not like calling anyone out. I mean, it's like, I probably would have tried to do the same thing. You have that hubris of like, yeah, sure, just sanitize the JavaScript. It just turns out you can't like sanitize a program. It's just too hard. And ultimately what you need to do this safely is you need to put that program in a box, right? You need to understand, like, I'm never going to be able to make this program safe. I just need to run it in a box. And I kind of think of it like, those like, when they're doing like biology and chemistry, they have those glove box things where they put their hands in the thing. It's kind of like that, right? It's like, there's no amount of precaution I can take other than just making sure that if the worst thing happens, all this is in a box and I'm safe. So what is that box? It's WebAssembly. So WebAssembly is everywhere. It's in your pockets. It's on your watch. If you're bored right now, you're probably looking at it on your phone. It's in the TV. It's probably in your car. It's probably in your fridge. It's all over the place. It's in all the browsers. It's on all the computers. And what is WebAssembly exactly? Well, what it is basically like a small virtual machine. And instead of like, JavaScript runs like JavaScript code. It can like parse it, compile it, run it in its own little virtual machine. Instead of that, it jumps straight to just like the bytecode. So it's like kind of more like the JVM or something. Like, you don't put source code into it. You put a very tight, efficient, compact bytecode into it. And it also has like no concept of like types or memory allocation or garbage collection or any of those things. So it works really well with like low-level languages. And you might have kind of like heard about it in the past as just kind of a way to like take C programs and compile them and run it on the web. And that's sort of how it initially started, was a way to like run this kind of software that needs high performance to port a bunch of existing code from other languages over to the browser. And you might remember seeing like Doom, like around the time WebAssembly started coming out, you see like Doom demos and stuff like that. So yeah, that's typically how people remember it, right? But there's this other property about WebAssembly. So it's also a memory-safe sandbox execution environment. So they made this other decision when they built WebAssembly. Because it runs in the browser, like when you think about it, when you go to like CNN.com, right, it's like you're just pulling hundreds of scripts from all over the place and just running them on your computer. Even CNN doesn't know where that code is coming from. It's all over the place, and you just don't even sweat. You're just like, whatever, it's fine. Why is that? Because a lot of people spend a lot of time and money making sure that JavaScript is sandboxed from your computer. So you know that that script is not going to like open a file, make some network calls it shouldn't. So they knew that WebAssembly also needed to have the same level of security guarantees. So they built it, with this in mind. And what is a WebAssembly program exactly? You'll usually see them in this .wasm format, and it's just a binary format. And it's a code module. It's just like a JavaScript module, really, like in theory. It's just got functions. It's got some internal functions. It can export functions. It can import functions. But these functions are abstract of any language. They're just functions. And so if we can just like take our plugin and compile it in a way to where it's exporting those three things that we need, then it can act as our plugin. Is that kind of making sense? It's probably getting a little bit confusing, but but understand that it's like, think of it like just like a JavaScript module. It's like just a thing with some exports that you can call. And what it looks like in like the normal world is it looks kind of like what we did with the eval, right? It's like you get your data, you get your module up here, we're getting it with fetch, we're turning it into bytes, but it's not too different from like having the JavaScript code. Create a WebAssembly module, we instantiate it, and now we have handles to the export functions. So we can call our git config, we can call our process, all that stuff. Sort of makes sense, everybody? Okay. But it's not that easy. So these aren't just like, they are functions, you can call them, but this is like pretty much all the data types that WebAssembly knows about. So 32-bit, 64-bit integers, 32-bit, 64-bit floats. All right, we can make calculators, right? Not really a lot you can do with that. So there's a lot that goes into creating that interoperability between languages. And that's where XISM comes in. So XISM is a universal way to where no matter what language your WebAssembly module is written in, you can just kind of call it like it's normal JavaScript stuff. It also takes it one step further by, it doesn't matter what's on this side either. It doesn't matter what your application is written in either. It can also be any language. So it's like a universal ABI and a bunch of tools to make that easy. Let's look at the demo. So let's look at some code. So this is where you guys can start making fun of me. I write all my front-end apps in index.html. So we're going to look at that. And I wrote, you know, this Photoshop thing. And really all this is actually let's do the demo. Let's run it. So yeah, this is the app that we described, and we can, you know, invert an image. We can invert it back. We can do our little blur, and we could change. I couldn't get a slider to work in React, so it's a number field. So we could change the blur. I added one little like extra little fun thing here. We can memify it. So yeah, that's the app. So what's the code look like? It's pretty simple. We have like just a list of these plugins, and the plugins are XISM plugins. So XISM comes with this idea of a plugin. And we have our image. And basically all we're doing is we're just looping through our plugins and calling process on them. And when you create a plugin, all you have to do is call XISM's create plugin, and you pass in a path to the Wasm module. And here we're just going to call our get config. So we're going to say like what variables do you support. And one of the easiest ways to pass data back and forth with XISM is just to use something like JSON. So here we're just saying this returns those variables, but in JSON form. So we're just going to parse the JSON. So you can kind of think of it sort of like an API, but really it could just be like whatever format you want. Yeah, and then of course, like on our var changes, we call our set variable with our value, and then that's how we update the state and change the app. So it's really that simple. Let's go back to our slides here. Oh, and I think I wanted to show one more thing. So yeah, so like I said, this works in the browser, but WebAssembly is no longer confined to the browser. It's escaped. It's everywhere. So we support, I don't even know how many. I think probably a couple dozen languages. This is not an up-to-date list. I don't know how to count how many languages we support, but we support running these modules in pretty much any language. And just to show you what I mean by that, so we have our plugins here. And this application, so this XISM program right here is written in Go. And we're just going to take that same invert plugin and then just pass in an image and just say call the process function on it. And then when we open the image, it should be inverted, right? So it doesn't matter where you're running these things from. You can pass these plugins around to your front end, to your back end, any language, it doesn't matter. They'll run everywhere. So it's also just a really cool way to like reuse code, right? Like if you can turn your code into WebAssembly, it doesn't matter what language people are running, like it'll just go all over the place. And it's pretty fast. Like I wrote these in Rust, so they would be extra fast, but it's pretty fast even in like, you can embed JavaScript. It's pretty fast. But you can make it as fast as you want. Like if you want to write it in Rust or C, you can. And because it's so low level, and handles all the memory stuff for you. It works really well. Yeah, let's go back to our slides. So, okay, last thing I want to talk about. So this is like kind of a specific example, and it's like, I was kind of talking about building something sort of like Figma, where like the plugins are kind of the point. But I think like what I would like for people to take away is like looking at your application and looking at every interface that you have where things are decoupled and thinking about it as a potential plugin, right? Like once you've already done the work to decouple some part of your application, why not let a customer write that? And what I mean is this, like maybe this is a little too on the nose, but if you've ever worked like for a company that is growing and has lots of customers and things are getting complicated, you have lots of customers coming to you and they're like, oh, we need like when Dom and I worked at Recurly, there was a lot of like, okay, when an invoice happens, we need like this kind of particular logic to happen. And you end up building these like super complicated UIs. They maybe don't look this on the nose, but you've probably built similar things where it's like, okay, I'm adding one more situation where when this happens, this other thing's supposed to happen for this customer. And you're kind of like, which customer's paying me the most? How am I going to build features that like satisfy them? Or how can I build features that satisfy multiple customers at once? And it's this crazy dance. But really, you're just kind of building a terrible programming language. I mean, this is just a bad programming language. What if you were just like, give me the JavaScript that describes what logic you want? Just use a Turing-complete language in any language that you want to just tell me what you want to happen when you generate an invoice, and we'll just run that for you. Because we can now, because we can do it safely. And we've like not really had this capability for a long time, so I feel like we've invented all this junk around this problem. And now that we have it, it's like we can probably get rid of a lot of that junk. And that's it. Last thing to follow up on. So if you're kind of interested in plugin systems and more about a little bit of the higher level, kind of like the history of plugins, the future of plugins, I would recommend watching this talk I gave, I don't know, like 6 months ago or something. It's called Why You Need a Universal Plugin System. It's on YouTube. Also, another super powerful concept is host functions, which I don't really have time to get into, but is like really it's really the thing that like it's really the thing that takes this stuff to the next level. Like it makes it a lot more powerful. And XSystem has support for host functions, but it's a much too complicated topic to like describe in this talk. Last thing, please come to this talk next month. So I run a meetup called Below Sea Level. Dom is going to do a talk there, who's my colleague at Dilipso, about Wasm, and just kind of like, if you're curious more about Wasm and other ways it can be used and like how it works, like he's going to go into sort of unpacking a lot of that stuff, right? And explaining different use cases, explaining how it works and why you should care about it just beyond like this one sort of use case. Yeah, that's it. Cool. Any particular questions? Or?
So with it being sandbox, do you have to deal with like shuffling data in and out of the sandbox?
You do.
Big example, like what does it look like to actually get that configuration out of it?
It's up to you. You do have to deal with it, but XSystem makes it as easy as possible. Like you have to deal with it at some point. Like what he's saying is basically, because it's a sandbox, the plugin can't manipulate memory in the host. So basically the plugin has to say like, here's this config data, and here's a pointer to it, and come get it out of my memory. And it has to copy it out. We make it a little bit more like, our interface is basically, every function is optional bytes in and optional bytes out. And then you just decide, it's like HTTP, like you just decide what those are. In the future, you know, there's other things that you can do, like with host functions, you can do more nuanced things. If you want like the plugin to have a pointer to something in the host, where it's not copying data, but that's like kind of way more advanced, huh?
You decide ahead of time that like it's safe for it to touch this memory.
No, you basically just expose you expose the host function with an opaque pointer, and you just say, just pass me this pointer, and then tell me what you want to do with this to this data. So, you know, it's not manipulating the data, the host is doing it on the plugin's behalf. And if it's not a real pointer, then it can't actually dereference anything, it's just a fake pointer.
So if it's in our cars and stuff like that, and I know you're saying like it's sandbox, but there's got to be, I mean, we know like car manufacturers aren't like the most secure places. They have like a lot of exposed information. Can it be used to, I mean, can a bad actor, or I should say, a bad actor use it to do anything malicious to your car or yourself? Maybe you want to do something interesting with like the UI.
So first off, I would note, even though like this is in your car, it's not necessarily being like used in your car, it's just there. Like, so I guess what I was getting at is like the virtual machine is like there. So if you go into a Tesla, like all that stuff is like, I think it probably still is mostly like a lot of browser-based stuff, right? And if there's a browser, if there's V8 there, then there's a Wasm runtime there. And to your question, it's like the people who are developing these runtimes are mainly people who are developing the browser runtime. So they're pretty like tested at scale. Like again, if you don't feel sweating going to CNN.com, like you're probably okay, right? Because it's like there's a lot of there like probably will be vulnerabilities in the future, and there are every once in a while, but there's a lot of effort and time. It's equally as safe as the browser, is what I'm saying.
That's fair.
Like nobody ever thinks like, oh, I'm gonna go to this web page and it's gonna like install like a Trojan on my machine. Like your browser like protects you from all that, unless obviously you click on something. But you get what I'm saying. Yeah.
So is exorcism not a runtime implementation, or is it a runtime or not a runtime?
Yeah. So Exorcism historically was a wrapper around a WebAssembly runtime called Wasm time, but very early on we built it to be abstract from the one time. So now Exorcism is a Wasm module, and it's so Exorcism is Wasm, and because of that we can run it in any WebAssembly runtime. So if you're in the browser, it's going to use the browsers. If you're in Rust, it's going to use Wasm time. If you're in Go, it's going to use WAS0. So it's going to use whatever is the best runtime for that environment.
So I think what you're saying is exorcism is that thing that helps you build the plugins for the runtime.
Yeah, so Exorcism is basically a universal ABI. So it's the thing that helps you pretend like you're just talking to functions and you're just dealing with bytes. And it handles the communication between them, and it handles a lot of the stuff around it. And we have this concept of like SDKs and PDKs. And you know, if you have like a Rails app, all you need to do is go download our Ruby SDK, and you can run Exorcism plugins. And then we have a bunch of other PDKs for building the plugins themselves in different languages. Or you can just use existing Exorcism plugins that do existing stuff. Is it? Cool.
Are you making all these modules like Ruby, Node, C? You're building each one individually, or is that also like a community project?
For the most part, like we are doing everything ourselves, but we did it in a way. We did it really early on, so that's kind of a whole nother talk in itself. But like I've been for a pretty long time, like me and the other co-founders are pretty like comfortable. Like I've worked, like my last job, like I was writing like 8 programming languages a day. Like we were all like really fluid and knowledgeable about like programming language stuff and building programming language infrastructure and tools. So we're all comfortable jumping into any programming language, but really what it's about is just building a particular type of shell and using some tricks to just make it really easy to add a new language. So I would say like 80% of them have been us, and then like over the past 6 months or so, people in the community have come in and contributed like D programming language, like someone contributed that. And like someone has come in and done Zig, and it's like, those are languages that we never really thought to do, but then people have just done it for us because we made it pretty easy.